This video is brought to you by Altium. I have been using ESP32 Wi-Fi plus Bluetooth module for controlling electrical devices from anywhere in the world using the Blink IoT platform, which is no doubt one of the most popular IoT platform for monitoring and controlling things over long distances. I have also used ESP32 with the IFTTT Google Assistant for controlling AC and DC loads over long distances using Wi-Fi as the communication medium. When building a home automation system or office automation system, I always prefer ESP32 or ESP8266 because the ESP32 comes with a built-in Bluetooth module that I can use for controlling things over a short distance. I have a very detailed tutorial on how to control AC and DC loads using the ESP32 built-in Bluetooth module and an Android cell phone application. Recently, I built another home automation system using ESP32 and an IR remote controller for controlling 220-volt AC light bulbs. This IR remote controller based home automation system is for those guys who don't want to rely on the internet availability or don't want to use a cell phone. I highly recommend you should watch this IR remote controller based home automation system because today's episode is entirely based on this project, as I'll be using the same ESP32 development board and the same lights, so I will not explain the things which I have already explained in my previous video. In today's episode, you will learn how to use ESP32 as the web server and a cell phone or a laptop as the client for controlling home appliances or other electrical devices using Wi-Fi as the communication medium. So before I'm going to explain the circuit diagram and programming, first let's watch this ESP32 web server based home automation system in action. I simply start off by entering the IP address of the ESP32 module which I'm using as the web server. I will explain in detail how to get this IP address. You don't have to design this web page. All the coding is done on the ESP32 side. These buttons are automatically created, but you have full control over all these buttons. You can change the design, you can increase or decrease the number of buttons, you can make all these changes in the ESP32 programming. Anyways, you can also enter the IP address in your cell phone and this way you can get access to the ESP32 web server. If you don't want to use other IoT platforms, then this is how you can design your own dashboard. You can also design your own gauges for displaying the sensors data. It depends on your interest and how much time you spend on coding. I have been testing this project for the last 3 hours and I didn't see any bugs, malfunction and false triggering. Now you have got the idea of what exactly you are going to learn after watching this video. Without any further delay, let's get started.
Access granted.
The components and tools used in this project can be purchased from Amazon. The components purchase links are given in the description. J1 is the DC female power jack and this is where we connect a 12-volt adapter, battery or a solar panel. Two 470 microfarad capacitors are connected at the input and output sides of the voltage regulator. The output of the voltage regulator is connected with the 5-volt pin of the ESP32 module and the ground of the power supply is connected with the ground of the ESP32 module. These are the 12-volt ESP32 type relays and can't be directly controlled using the ESP32 module. So that's why we need a driver to control these relays. You can use a relay driver IC or you can use 2N2222 NPN transistor and a 10 kilo ohm resistor. One pin of the relay coil is connected with the collector of the 2N2222 NPN transistor, while the other pin of the relay coil is connected with the 12 volts. The emitter of the transistor is connected with the ground, while the base is connected with the 10 kilo ohm resistor. Now to control these relays, you simply need to connect these 10 kilo ohm resistors with the ESP32 IR pins. In this project, I'm using the GPIO pins 13, 12, 14 and 27. I'll be using the same pins in the programming. The neutral wire from the 110 or 220 volt AC supply is connected with the neutral of all the lights, while the live wire from the AC supply is connected with the lights through these relays. Here is my ESP32 development board. If you want to make the same development board, then you can watch my previous video. I will provide a link in the description. The lights connection with the relays remains exactly the same as I explained in my previous project, IR remote controller based home automation. Now let's take a look at the ESP32 Webserver based home automation project programming.
This video is sponsored by Altium. Altium Designer is the world's most trusted PCB design system. Altium Designer enables engineers to effortlessly connect with every facet of the electronics design process. Over 35 years of innovation and development focused on a truly unified design environment makes it the most widely used PCB design solution. With Altium Designer, you can create PCB designs with an intuitive and powerful interface that connects you to every aspect of the electronics design process. Route it your way through any angle, tune for delay, push, slide and walk around faster than ever. Interact and collaborate with mechanical designers like never before in a photorealistic 3D design environment. If you want to get started with the Altium Designer, you can click on the first link in the description.
If this is your first time using ESP32 Wi-Fi module, then first you will need to install the ESP32 board. I have a very detailed video on this. I will provide a link in the description. This is the name of the Wi-Fi router and this is the password. I'm using pins 13, 12, 14 and 27 to which all the 4 relays are connected. This line of code prints the IP address. Maximum of the code I have already explained in my previous ESP32 based projects, and 20 to 30% of the code only makes sense to those who have a little knowledge of the HTML coding. Anyway, for detailed explanation, read my article available on electronicclinic.com. I have already uploaded this program, and now let's watch this ESP32 web server based home automation project in action. To control the home appliances or other electrical loads using a web page, first we will need the IP address of the ESP32 module, which we are using as the web server. Now to find the IP address, first we will need to connect the ESP32 module with the laptop. Next, open the serial monitor and make sure the ESP32 module is connected with the Wi-Fi. Copy the IP address. For this, simply press Ctrl+C on the keyboard. After this, disconnect the USB cable. Power up the ESP32 module. I'm using my homemade 4S lithium-ion battery pack. If you want, you can use a 12-volt adapter. Next, connect the 110 or 220 volt AC wires to power up the lights. Finally, open the internet browser. Paste the IP address and press the enter key on your keyboard and start controlling your home appliances. In my case, I'm controlling 4 lights. While the 110 or 220 volt AC wires are connected, never touch the relay contacts as it can be really dangerous. So that's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.